Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting up the arithmetic section for Meet 3, so let's get into it. Alright, so the first main thing that shows up in arithmetic Meet 3 is exponents. So we're going to go over what an exponent is and how you use them. So when you have an exponent, it's some number to the power of some number, and it's in the form of a to the power of n, where a is the first number, and n is the power that's being raised to. So what this means essentially is that you multiply n a's together. So an example would be if I had a to the power of 4, because 4 is in the place of n and n is the power it's being raised to, then that means you multiply n a's together, or since n is 4, you multiply 4 a's together, which would be a times a times a times a. So a to the power of 4 is just when you multiply a by itself 4 times. Now, something that some people get confused on and mix this up, which will actually give you the incorrect answer, is it does not mean a times 4. If you wanted to do a times 4, you would write it out like that. But having an exponent means you multiply it by itself however many times the exponent is. So when the exponent, or n, is 4, then you multiply the number by itself 4 times. And then these are some examples with other numbers. 6 to the power of 3 would be 6 times 6 times 6. Which is 216. And when we go to the power of 3, or have 3 as n, we call that cubed. 2 to the power of 6 would be 2 times 2 times 2 times 2 times 2 times 2, because that's 2 multiplied by itself 6 times, and that gives you 64. And 17 to the power of 1 gives you 17, because you only multiply 17 by itself 1 time, which means you only have 17. All right. There are also a few special cases when it comes to exponents. Now, when n is when n is 1 and above, and it's a whole number, it's really easy to figure out what it means. But there are some special cases, like when n might be 0, that you need to know. So if anything is to the power of 0, then it's always going to be equal to 1. So as examples, I have 2 to the power of 0, which is 1, 3 to the power of 0, which is 1, and 1,382,380 to the power of 0, which is also 1. So this is essentially how powers work with 0. Anything to the power of 0 is always going to have to be 1. So you don't even have to worry about how many times you multiply the number by itself. If it's to the power of 0, it equals 1. And then a second special case is if you have a negative exponent. So if you have an exponent in the form of a to the power of negative n, it's equal to the reciprocal of a to the power of n. So you might be wondering what reciprocal means. So basically what reciprocal means is if you have a number, say I took the number 3 as an example, it's what number do you multiply by 3 to get to make it 1. So what number can I multiply by 3 to get it equal to 1? So 3 times 1/3 would equal 1. So therefore, the reciprocal of 3 is 1/3. If I had the example 2/7, and I had to figure out the reciprocal of that, it's what number times 2/7 equals 1. And the answer is 7/2. 2/7 times 7/2 equals 1. So the reciprocal of 2/7 is 7/2. And I know this seems a little bit complicated, but it's actually really easy to find the reciprocal of any number. All you have to do is write that number as a fraction. Maybe it's an improper fraction, maybe it's not, and just flip the numerator and denominator. So let me show you. If I wrote 3 as a fraction, it'd be 3/1, because it's 3 divided by 1, which is just 3. Now, if I flip the numerator and denominator, at the top and bottom number, that gives me 1/3. So the reciprocal of 3 is 1/3. And with 2/7, this one's a little more simple. Your denominator is 7, numerator is 2. So if you flip them, that gives you 7/2, which is your reciprocal of 2/7. So now let's look at our examples. So when I have 3 to the power of -4, it's just the reciprocal of a to the power of n. So we have a to the negative n, so 3 to the -4. So a to the n then in this case would be 3 to the 4. And the reciprocal of 3 to the power of 4, because this is over 1, will give us 1/3 to the power of 4. So 1/3 to the power of 4 equals 3 to the power of -4. Similarly, if we had 2 to the power of -1, then 2 to the negative, or a to the negative n would be 2 to the -1. So therefore, a to the n would be 2 to the 1. And the reciprocal of 2 to the 1 is And if we put it over 1, we can see this more easily. 1 over 2 to the 1. So therefore, 1 over 2, because 2 to the 1 is 2, would be equal to 2 to the power of negative 1. And then in this example, we had 7 to the power of 3 over 2 to the power of 3 as our answer to 2 over 7 to the power of negative 3. And the reason why is because if we do 2 over 7 to the power of 3, and now we find its reciprocal, that's 1 over 2 to the 7, right? So you can do it this way. You can do 1 divided by whatever number. But you could also just switch the numerator and denominator. So 7 over 2 would be my reciprocal of 2 to the 7. And then that's to the power of 3 and to the power of 3. Because remember, it's still to the power of 3. So 7 over 2 to the power of 3 is equal to 2/7 to the power of negative 3. So there are actually a few special tricks that you can apply when you're doing operations with exponents, but the exponents are on the same number. So you can simplify the powers of the same number like this. So when you're multiplying a to the power of n times a to the power of m, where a is the same number both times, and n and m are two exponents in different powers of a, then that's going to equal a to the power of n plus m. Similarly, if you have a to the power of n divided by a to the power of m, that's going to be equal to a to the power of n minus m. And then finally, if you have a to the power of n, and then that's to the power of m, then you can just simplify to a to the power of n times m. So let me show you some examples of what this actually looks like with real numbers. So if I had 3 to the power of 5 times 3 to the power of negative 3, this formula tells us that we can just add n and m, which are the two exponents, since we have the powers of the same number, which is 3, to get 5 plus negative 3, which is 5 minus 3, and that gives us 2. So 3 to the power of 5 times 3 to the negative 3 is 3 to the power of 2, or 3 squared. Next, if we had 2 to the power of 12 divided by 2 to the power of 8, since we're using the same number, 2, we can just subtract the exponents. So 12 minus 8 would give us 2 to the power of 4. And then since we have 4 here, to the power of 2 to the power of negative 3, because that's outside the parentheses, then we can multiply our exponents, because it says a to the power of n to the power of m equals a to the power of n times m. So therefore, 4 to the power of 2 to the power of negative 3 equals 4 to the power of 2 times negative 3, and that gives us 4 to the power of negative 6. All right, so now I have a review question on operations on different powers. If you'd like to try it, I'll give you a few seconds to pause the video and then explain the answer. So the correct answer to this question was 43. So let's start and look at the question. So we have 2 to the power of 2 to the power of 2 plus 3 to the power of negative 2 times 3 to the power of 5. So if you remember our trick from the last slide to simplifying expressions with powers of the same number, you'll be able to simplify both of these sections to make it a little bit easier. So let's start with the first one. So we can simplify 2 to the power of 2 to the power of 2 to 2 to the power of 2 times 2. Because remember, whenever you have a number raised to a power inside of parentheses and then raised to another power outside of the parentheses, you can multiply those two powers together and it can just simplify it to 2 to the power of 4 in this case. So this simplifies to 2 to the power of 4. And then that's plus, and then since we're multiplying 3 to the power of negative 2 and 3 to the power of 5, since it's multiplication, we can add the exponents. So 3 to the power of negative 2 plus 5. And negative 2 plus 5 is 3. So this simplifies to 2 to the power of 4 plus 3 to the power of 3. Now we just have to simplify these exponents. 2 to the power of 4 means 2 times 2 times 2, and then times 2. And then 3 to the power of 3 means 3 times 3 times 3. And then when you simplify those out, that gives you 16 plus 27, and 16 plus 27 gives you 43. All right, so and the other thing that comes up in Arithmetic Me 3 is roots. So roots are actually really similar to exponents, and we'll get into that in a bit. So a root is defined as a number that when multiplied by itself a certain amount of times, returns the value of the number you found the root of. So it's kind of hard to define a root, so I'm going to explain it through example. So here I have the equations. 4 times 4 times 4 is 64. 2 times 2 is 4. And 3 times 3 times 3 times 3 is 81. So therefore, 4 to the power of 3 equals 64. 2 to the power of 2 equals 4. And 3 to the power of 4 equals 81. But we can also put this in the form of a root. So here's what I mean. We could say the third root of 64 is 4. And the second root of 4 is 2. And we could also say the fourth root of 81 is 3. So this is essentially what roots are. Roots are basically the opposites of powers. When you raise a number to a power, the result will have the root as the number that you raised to the power of something. So therefore, if I wanted to find the third root of 64, and this is how you write the root symbol to the root of 3, right? The third root of 64, which we also call the cube root, that's going to equal 4. If I want to find the square root of 4, because when we find the second root, we call it the square root, that equals 2. And if I wanted to find the fourth root of 81, that would be 3. Now, one piece of information that I didn't mention earlier about exponents, but I'm going to mention now because I just explained what roots are, is that you can actually express a root as an exponent. So this is what I mean. Say I want to find the second root of 64. So find the square root of 64. I could write it like this. Find the square root of 64, just like that. And when you're finding square root, you actually don't need this 2 here because it's just assumed you mean the square root. So if I want to say find the square root of 64 and I need to write square root in my question, I could write it like this. But you can also express that as an exponent. So you could also write 64 to the power of 1/2. And here's how this works. When you have an exponent that's a fraction, what the numerator represents, which is the top number, is what it's raised to the power of, like the positive exponent, or how many times you multiply it by itself. And then what the denominator represents is what root you're finding of that number. So when I have 1/2 as my exponent, the 1 represents that's just 64 because you're not raising it to the power of anything. But the divided by 2, or the 2 in the denominator, means you're finding the second root. Now, similarly, if you had, say, 3 to the power of 3/4, what this would mean is you're raising 3 to the power of 3, because there's a 3 in the numerator, and you're finding the fourth root of that, because that's in the denominator. So that would look like this. 3 to the power of 3/4 is 3 to the power of 3, and then the fourth root of that. All right, so now that we got that, I'll keep continuing to talk about roots. So the next thing you need to know about roots, and it's really something that you actually need to memorize, are all these roots down here. Now, I know it looks like it's a lot to memorize, but you're going to use these numbers so much, and you probably already have, that you already have a lot of them memorized, especially the square roots. Now, this really, really helps when it comes to finding roots of large numbers and finding square roots of large numbers and so on, because you're going to get a lot of large numbers that have good roots in them. Like, you're going to get, maybe in a question, it's going to end up being the third root of 2 under 16. And if you know that's 6, then you already saved a lot of time thinking about that. Because there's no really good method just to find the root of a perfect cube or a perfect square or whatever. This will also help if you're finding the root of numbers that aren't perfect cubes or perfect squares. But we'll get to that in the next slide. But for now, I'm just going to let you look at this for a sec. Oops. I'll just let you look at this for a sec to see which ones I recommend you memorize. So next we're going to talk about finding and simplifying roots, especially of roots that have irrational endings. So before we get to that though, you do need to know one rule about roots. And that's when you find the square root, or any root of a times b, that will equal the root of a times the root of b. And so the reason I said any root is because what I mean by this is, say you had the square root of a times b, then that's going to equal the square root of a times the square root of b. Or if it was the 6th root of a times b, that will equal the 6th root of a times the 6th root of b. So let's look at what that looks like with actual numbers. So because 6 is equal to 3 times 2, if I were finding the square root of 6, that would be equal to the square root of 3 times the square root of 2. And if you think about this, It's basically if we're finding the square root of 6, that's equal to the square root of 3 times 2, right? Because 3 times 2 is 6. And using this rule up above, when you have a times b, which are two numbers multiplied by each other, that's equal to the square root of the first number, a, times the square root of the second number, or b. So basically, you can simplify the square root of a number to the square root of two of its factors multiplied by each other. And when those two factors are multiplied, they get you to that original number. All right, so continuing on with roots, we also need to talk about irrational roots. So essentially, irrational roots are roots that end, irrational roots are roots that don't end, should I say. So some roots are not going to be rational, which means they have decimals that go on forever. So in example, the square root of 2 is about equivalent to 1.414213. But it doesn't stop at that 3. It actually continues on forever without a pattern. That's what we call irrational. And so since it continues on forever, we can't write out all those numbers. So instead, when we find the roots of larger numbers that have an irrational root, instead of just trying to write out all the digits in that decimal, because we can't because it goes on forever, we simplify it to an integer multiplied by the root of another integer in the form of a times b, or a times the square root of b. So essentially, when we have this root of a big number that has, or when we have the root of a big number that has an irrational root, instead of finding that irrational root, we just simplify that root down. So here's what that looks like in practice. So since 80 and 75 are both not perfect squares, when you find the square root of them, they're going to equal irrational numbers. So instead of writing out those irrational numbers, we simplify it like this. We can say the square root of 80 equals 4 times the square root of 5, and the square root of 75 equals 5 times the square root of 3. Now this might be confusing, but basically, remember, a root, or the square root is a number that when you multiply it by itself, it equals the original number. So therefore, 4 times the square root of 5 should equal 80. And if we multiply it out, 4 times the square root of 5 multiplied by 4 times the square root of 5, it actually does equal 80. So let me show you. If we move around the multiplication here, since this is all multiplication, we can choose what to multiply first. So if I multiply the 4s by each other and the square roots of 5s by each other, just like this, then the 4 times 4 gives us 16. The square root of 5s multiplied by each other gives us 5, because if you think about it, the square root of 5 times the square root of 5 equals 5. And then 16 times 5 is 80. So this is how we simplify down roots. We have a number on the outside that's an integer that we multiply, and on the inside, we have a number that has an irrational root, but it's a smaller number, so we can kind of get a grasp of how big this number we're talking about is. So we just talked about what the simplification of irrational roots of numbers looked like. So now I'm going to show you how to find that simplification, where you're finding the root of x, and that's going to be equal to a times the square root of b. Now, just to let you know, this method that I'm about to teach you, this only applies to simplifying square roots of irrational numbers, or sorry, to simplifying the square root of numbers that'll give you an irrational root. So I'm going to be finding the square root of 180, and I'll explain why this only applies to square roots at the end. So if I'm finding the square root of 180 and I'm simplifying it, then x is 180 because it's the square root of x. So your first step is to find the largest square number that x is divisible by. Because in the end, you want to be able to find what a and b are, and this is what's going to help you do it. So the largest square number that x is divisible by, or 180 is divisible by, is 36, right? Now, it's divisible by other square numbers, such as 4 and 9, but 4 and 9 are not the largest ones, so we don't really care about those ones actually. So we need to find the largest one, which is 36. So now that we know the largest square number x is divisible by is 36, now we can find the values of a and b. So in order to find the value of a, you use the square root of that number as the value of a. So remember, 36 was the largest square number 180 was divisible by, so therefore the square root of 36 is going to equal a. And the square root of 36 in this case is 6, so the value of a is 6. And then in order to find b, all you have to do is divide x by that square number, and that will be the value of b. So 180 divided by, oops, I wrote 6 here, but I meant to write 36. So if I divide 180 by 36, which is this square number, remember, that we found that 180 was divisible by, that's going to be our value of b. 180 over 36 is 5, so 5 is our value of b. And since a is 6 and b is 5, you can write out your simplification of the root as square root of 180 equals 6 times the square root of 5. All right, so now we're going to go over why this works, where you find the largest square number is divisible by. The square root of that number is a, and if you divide x by that square number, it's b. So we're going to talk about why this works. So remember that rule that I was telling you about, where if you're finding the square root of a times b, that's going to be, that's also equal to the square root of a times the square root of b. So the reason that this rule is helpful in explaining why this simplification works is because if we think about what we can simplify the square root of 180 down into, we could simplify it into the square root of a square number multiplied by the square root of another number. So let me show you what I mean. So if I took the square root of 180, well, a times b, remember, are just two numbers that multiply to 180 in this case. And I know that two numbers that multiply to 180 are 36 and 5, right? 36 times 5 equals 180. So technically, if I'm finding the square root of 180, this is actually just the square root of 36 times 5. And since the square root of two numbers multiplied equals the square root of those individual numbers multiplied, so since the square root of 36 times 5 equals the square root of 36 times the square root of 5, then I can write it out like this. And since the square root of 36 is a whole number, it's just 6, that's how I simplify it down. So this technically simplifies to 6 times the square root of 5. And this is the whole idea of simplification. We want the largest possible whole number on the outside, right? We want to remove as much irrationality as we can. And we want the smallest possible number that's not a perfect square on the inside of the square root. So this is why we simplify it into this is why when we simplify it down and when you find the largest square number, this is why it has to be a square number, because you're using this in order to find the square root of that number as a whole number. In this case, we found it to be 6. And then you're using the remainder when you divide it as just the square root that you're keeping, because you want to simplify that number inside the square root as small down as possible. So this is exactly how you do it. Now, the reason that I said this only works for square roots is because I told you to find the largest square number that x is divisible by. Say you're finding the cube root of 54, for example. Then in order to simplify that, you don't want to find the largest square number 54 is divisible by. And that just kind of logically makes sense, because think about it. We're talking about cubes. You want to find the largest cubic number that 54 is divisible by, which is 27. And if you follow the same steps, instead of using the square root, say you found the cube root of 27, so cube root of 27, that would equal 3. So 3 would be a, and then divide 54 by 27, that's 2. So the cube root of 54 simplified would be 3 times the square root of 2. And this is why this only works for squares. And to explain why you have to change it for when it's not a square, it's because if I explained it the same way I explained why this works for square numbers, then this cube root of 54, and since 54 is technically 27 times 2, equals the cube root of 27 times the cube root of 2. And this is why we have to find a cubic number, because remember, we simplify it out to cube roots multiplied by each other. And then you can simplify this cube root of 27 to 3, and that's why you have to find cube roots. And if you're finding the fourth root, you'd have to find the largest, I don't actually know the name, largest number to the power of 4 that your original number is divisible by. If you're finding the fifth root, then you have to find the largest number to the power of 5 that your original number is divisible by, and so on. But if you're just talking about square numbers, you find the largest square, or if you're just talking about the square root, you find the largest square number that x is divisible by, and follow these steps. Right, so now I have a review question about simplifying irrational roots. If you'd like to try it, I'll give you a few seconds to pause the video and then explain the answer. So the correct answer to this question was 2 times the third root of 7. All right, so here's how we'll simplify the third root of 56. So since we're finding the cube root Then our first step is to find the largest cubic number that 56 is divisible by. So if we think about what numbers 56 is divisible by, eventually you'll come up with 8 as the largest cubic number that 56 is divisible by, because 8 is 2 times 2 times 2. All right, so now that we have 8, in order to find our value of a, which is our value on the outside, in this case is 2, but we don't know that yet technically, then all we need to do is find what the cube root of that largest cubic number that 56 was divisible by is. So since the cube root of 8 equals 2, then our outside number, or a, is going to equal 2. All right, and then our second step, in order to find what our value of b is, or the number that goes on the inside, is to divide 56 by that cube root, or by that cubic number. So 56 divided by 8 equals 7. So 7 is going to be the value of b. And remember, we're still talking about cube roots here, so we can't write 2 root 7. We have to write 2 times the third root of 7 as our final answer. And if you wanted to check that out, then you do 2 times this cube root of 7 times 2 times the cube root of 7. And this is just us checking our work to make sure we got it correct. And so that would, if you want to move around the multiplication to simplify it up, then you could simplify to 2 times 2 times the cube root of 7 times the cube root of 7. Oh, sorry. Remember, we're cubing this. So actually, you need to multiply it by itself 3 times. Forgot about that. Because remember, we're finding the cube root of 56, which is supposed to be this. So when we cube this, it'll equal 56. So I messed this up a bit. So 2 times 2 times 2 times the third root of 7 times the third root of 7 times the third root of 7 should give us 56. And this multiplies to 8. This multiplies to 7, because the third root of 7 to the power of 3, because it's being multiplied by itself 3 times, equals 7. And 8 times 7 is 56. All right, just to review what we've learned this lesson, we started by learning what exponents are, which is when you have a to the power of n, where basically what that means is you multiply a or n a's by each other. So a to the power of 4 would equal a times a times a times a. And remember, it's not a times 4. If we wanted a times 4, we'd write that out as its own, just a times 4. And then we looked at some examples with actual numbers. And then we learned about special cases of exponents, where anything to the power of 0 equals 1. And if you have something to a negative power, or a to the power of negative n, it will just equal the reciprocal of a to the power of n. So an example, 3 to the power of negative 4 equals the reciprocal of 3 to the power of 4, which is 1 divided by 3 to the power of 4. Next, we talked about special operations you can do on powers of the same number. So if you have a to the n times a to the m, that equals a times to the power of n plus m. If you have a to the n divided by a to the m, that equals a to the power of n minus m. And if you have a to the power of n to the power of m, that equals a to the power of n times m. And then we looked at some examples with actual numbers. And then we moved on to a review question where we found the value of 2 to the power of 2 to the power of 2 plus 3 to the power of negative 2 times 3 to the power of 5 to be 43. After that, we started talking about roots, which is a number that when multiplied by itself a certain amount of times returns the value of the number you found the root of. So an example, since 4 times 4 times 4 equals 64, the third root of 64 is 4. Or since 3 times 3 times 3 times 3 is 81, the fourth root of 81 is 3. Then we also talked about some roots you can memorize in order to simplify up some solving in the harder questions. Next, we talked about finding and simplifying roots. And we learned one rule about roots is that when you have this root of a times b, then you can simplify that to the root of a times the root of b. So an example, since 6 is equal to 3 times 2, the square root of 6 would equal the square root of 3 times the square root of 2. Then we learned that some roots aren't going to be rational numbers. For example, the square root of 2 is an irrational number, which means it repeats on forever. And since it repeats on it doesn't repeat on forever, it goes on forever. And since it goes on forever, we just write that as the simplified root of a number, or we simplify to an integer multiplied by the root of another integer in the form of a times the root of b. And so some examples where the square root of 80 equals 4 times the square root of 5, and the square root of 75 equals 5 times the square root of 3. Then finally, we talked about how to find these simplified roots, where if, in example, we have the square root of 180, your first step is to find the largest square number that number is divisible by, which is 36. Then you use the square root of that number as the value of a. The square root of 36 is 6, so 6 would be a. And divide x by that square number, and that will be b. So since 180 over 36 equals 5, and this is supposed to be 36, since that's 5, then our value of b would be 5. So the square root of 180 is 6 times the square root of 5. And then we learned that the reason this works is because you can break up square roots with that rule we learned, say 180 in an example, into the square roots of two numbers multiplied by each other. And when one of those numbers is a square number, then we can get as much irrationality out as we can, which is in this case 36, and the square root of 36 is 6. And then multiply that by the square root of the smallest number possible that returns an irrational root. And then finally, after that, we did a review question where we learned that the cube root of 56 simplified is 2 times the cube root of 7. All right, so that's all for today's lesson. I hope it was helpful, and I'll see you next time.